do you have any questions for me? Is there something that you would like me to start with? Something that you want to review? Anything from algebra pre-calculus? Or I will start with basically 3 topics. This is the review. I'm not starting chapter 2. Hopefully today, but not at this moment. So I want 3 things to look at. One is the average rate of change of a function between 2 points. The second one is something called difference quotient. And the last one is, it doesn't have to be this order, piecewise defined functions. These are crucial concepts in this class. So, again, do you have any questions for me before we start with this? Okay, I would like
Professor,
yes,
Professor,
yes, please.
the template you showed earlier on, that you said it was similar to what is in web design. Would it be beneficial if you go through that as well?
So,
or if you have the time?
So you're talking about this a plus b squared?
Yeah.
And the a minus b squared?
Right.
And a plus b, a minus b?
Mm-hmm.
Good. So this is a binomial squared, and this will always have 3 terms.
Okay.
So the first term squared plus 2 times the first times the second, and plus the second term squared. The a minus b squared is exactly the same, but has minus in the middle. So it will be a squared minus 2ab plus b squared. And this is something called the difference of squares. So it's a squared minus b squared. As an example, let's say if I have 2x squared plus 3y, and it's everything squared, I have to have 3 terms. And according to the formula, all I have to do is square the first term. When I square this, I get 4x to the 4th. I have to write plus, because this is plus. 2 times 2 is 4, times 3 is 12, x squared y, because this is 2 times the first times the second. 2 times 2x squared times 3y. 2 times 2 times 3 is 12, times x squared times y. And then the last one plus the second term squared. When I square 3y, I get 9y squared. You can say, but I can always FOIL. Yes, in beginning algebra, maybe in college algebra, but not in calculus. I don't recommend that in calculus. We should move away from that. And what about this one? So in order to apply it, I have, let's say, 2x minus y and 2x plus y. They have to be identical. Binomial, binomial, identical, except the sign in between. They have to be opposite. It doesn't matter if it's 2x plus y and then 2x minus y, or 2x minus y times 2x plus y. The formula is the same. I have to square the first term, 4x squared. I have to write minus, and I have to square the second term. And of course, these formulas are so-called dynamic. What does that mean? This implies that, and this implies this. This way is expanding. So from here, we are expanding. From here, we are factoring. Same thing here. Expanding, factoring. You will see how important these are keywords actually. So simplify, factor, these are keywords in math. We want to simplify always, and if factoring simplifies the problem, we should always factor. Any questions, anyone?
I have one. You said in calculus we should move away from FOIL. Is that because of FOIL being the acronym assuming it's only a binomial, or is there another reason?
No. The reason why I don't want to FOIL is because if I still need to FOIL, then I will really have difficulties when I integrate. I will have difficulties when I differentiate something complicated. I will have difficulties when I look at related rates. This is too basic. We are moving on to way more sophisticated concepts. It doesn't mean that we cannot understand these, but this is too basic. So if I'm at the stage in which I cannot square this to get these three terms, it means that I'm still having difficulties with a simple formula. And potentially these concepts will elude me. Potentially. Hopefully it's not the case. Does that answer your question?
Yes.
Thank you. So with practice, you should not need to factor. I have difficulties expanding. Also, I'm saying if we cannot get here quickly, we will have difficulties going here, which is way more important in factoring. So if I have difficulties determining this, I will most probably have difficulties in factoring. Not necessarily, it depends. Every brain works differently, but I'm just saying in general. I think if I can get here quickly, maybe I cannot get here easily. Good. Other questions? Very good. Very good questions. Thank you. Okay. So do you have anything else, or can we go back now to piecewise defined functions? I'm on page 2. I have to number my pages in the correct order, otherwise I may scan them in the incorrect. It never happened, but who knows? So piecewise defined functions. If you think of something, stop me, please. What is a piecewise defined function? Here's an example. I'm making stuff up. I don't know the percentages. I use TurboTax. So for someone who makes between 0, again, I'm making up numbers. Between 0 and $25,000 a year, 0% taxes. For someone who makes between 25,000 and 70,000, 15%. For someone who makes between 70,000 and 120,000 a year, I don't know, 20%. This is a piecewise defined function. Again, I don't know if these are the percentages. It was just an example. So piecewise defined functions are defined in pieces, not just one, but several, two, at least two or more. What's the big deal with piecewise defined functions? Well, the big deal is to evaluate and especially to graph. So to evaluate and especially to graph a piecewise defined function. And I would like to share my screen, if I can find the right mouse for this device. Okay, I think I did. Oh, but I'm logged out. So give me 1 second to log back in into WebAssign. It's screaming at me that I'm logged out. Wonderful. Okay. Because I would like us to choose a piecewise defined function and graph it. It's a very simple concept. I shouldn't say. I think it's a very easy concept. And many students have a lot of difficulty with it. Why? I'm not sure. Maybe you will tell me so that I can do a better job presenting it. Almost there. I had to log back in. Okay. It's the same, doesn't matter which class I click on, the ebook is the same. And here it is. Hopefully today. Ah, look at that. Okay. This is not what I wanted. I don't know what happened. I'll start again. It didn't take me to the book. I don't want to search for products. It's still logging me in or something, or I don't know what it's doing. Should be this difficult. Or maybe I clicked on something by mistake. Okay, finally. I'm only looking for a piecewise defined function. I know we're not there. Okay, so these are piecewise defined functions. I'm not going to answer their question. I'm just going to choose a function. A simple function like 21. So this is 21, and this is from section 2.5. I just copy the problem. f of x equals x plus 3 for x less than or equal to -1, and 2 to the x for x greater than -1. Disregard the rest. We only wanted to copy a piecewise defined function. Is this piecewise defined? Yes. How many pieces? 2. For any function, we're asked to graph, so that's the question here. Graph this function. So we always have to start with a domain. This is an absolute must. If you're asking, or if you ask me to graph a function, I will always find the domain first. Without the domain, I can't do anything. Can anyone explain what the domain is? Or say, oh, the domain is such and such. Anyone?
A list of all possible x values.
All possible x values that this function can be evaluated for. Thank you, Amanda. Very good. I got a sip of water. Good. So what I recommend is change this into an interval notation. Can anyone change this, x less than or equal to -1, into an interval notation, and then this one into the interval notation? Anyone, please.
The first one would be infinity to -1. With
you mean negative? You mean
infinity?
You mean negative infinity to -1?
Sorry, did I not say negative? Yes, and then a hard bracket on -1.
Perfect.
Right.
Yes, this is called closed or bracket. Good. What about this one?
X greater than -1.
With parentheses, parentheses -1, comma.
Infinity.
Very good. So now can anyone identify from this? Can anyone, so this is called open. These are called open or parentheses. Can anyone identify the domain for function f of x? Not for this piece or this piece. We already did. We want to identify the domain for function f of x. Can anyone tell?
It's negative infinity to infinity.
Very good. So perfect. So we have, the function has everything between -infinity and -1. It has -1, and then it starts immediately from -1, but not -1 to infinity. It means nothing is missing, so this is correct. The domain is all real numbers. The next step towards graphing any function is a table of ordered pairs. Mandatory table. You may prefer vertical tables, that are fine, acceptable, but x is on the x-axis. So I prefer this, but it's up to you. So this is f of x. Notice that the domain, you already told me, it's -infinity to infinity. But this turns out to be a very important point, or value if you want. So -1 has to be in the table. 0 will always be in the table. Even if the function is not defined, I'm going to show you what happens when it's not defined at a value. So allow me 1 second to stop this video.